Hello my dear students of class 9. Today we will learn the chapter 14, that is atmospheric pressure and wind. Here are the two terms, that is atmospheric pressure. So we know the term atmosphere. So what do you mean by atmosphere? Atmosphere means the air that covers our earth, and the term atmospheric pressure, which means the pressure that is exerted by this atmosphere. So here we will study about the atmospheric pressure and the wind. So in this chapter we covered the topics of introduction to the term of atmospheric pressure, how we can measure the atmospheric pressure. Next, we will also cover the factor affecting the atmosphere, the major pressure belts of the world, and also that is shifting of pressure belt. So now students, let's start. So here we see that air is defined as the physical substance. Why? Because it is a mixture of several gases present in the atmosphere and it has its own weight. So, let's discuss about the gases that present in the atmosphere. So, here we can see the constituents of the air, that are nitrogen, oxygen, carbon dioxide, argon, water vapor, and the gases. So in this pie diagram, we will see that the percentage of nitrogen is more than any other gases. So the percentage of nitrogen is 78%. So after that, here comes the oxygen. The oxygen is only 21%. Carbon dioxide is less than any other gases, that are 0.03%. Argon is 0.94, and the water vapor is variable, and the other gases is also present in the atmosphere. So from this we can know about the constituents of the air, in which the oxygen is the oxygen and nitrogen is the main constituents. So after this, the air that exert pressure on the earth's surface. So from this, the term air pressure, we can know that the air somehow exert pressure on the earth's surface. Let us define the word air pressure. The weight of air on a unit area of the earth is called air pressure. So the weight of the air that exerts on unit area. So in a unit area, the air has a weight, and in this area, in a unit area, the weight of the air is called air pressure. After this, the term atmospheric pressure refers to the force per unit area exerted against a surface by the weight of air above that surface, which means force per unit area, which means in an unit area the force that is exerted against on a surface, that is any kind of surface, by the weight of the air, which means the air exerted a pressure on any surface is called atmospheric pressure above that surface. So after this, the pressure is expressed in millibar, that is we call it MB millibar and is present with a mercury barometer. So we know that we measured the atmospheric condition or atmospheric pressure by barometer, and it is an instrument to measure the pressure. Barometer. The atmospheric pressure, the average atmospheric pressure at the sea level is 1013.25 millibar or 760, that is 760 millimeter. The height of the column of the mercury in the barometer at the sea level. So as we know that any type of measurement we can do about the height and the pressure, so it is related with the sea level. So what do you mean by sea level? The sea level means the level of the sea's surface. The atmospheric pressure decreases with the height. Why the atmospheric pressure decreases with the height? We will know it now. The atmospheric pressure decreases with the height because with the increasing in altitude or the height, the number of air molecule decreases. Here we see that the number of the air molecules decreases with the increasing height. So for this reason, the atmospheric pressure decreases with the height. If we go to the any mountains, the number of molecules there in the high altitude decreases, which exert less air pressure than the plain landforms. So here the atmospheric pressure is an important factor in producing and changing in weather. Producing and changing in weather, why we will call so? Because contrast in temperature causes changes in the air density. As we know previously that with the increasing in altitude, the density of the air decreases. So, which are responsible for the variation in pressure? This variation causes horizontal movement of the air. Horizontal means this way. This is the horizontal movement of the air. If the air moves horizontal in this horizontal direction, then it forms the wind. So, the wind transport heat and moisture from one region to another. As we know that air carries any type of moisture, and we called it moisture laden air to the another region, and thus help in the occurrence of precipitation, which also means rainfall. So precipitation is also called as rainfall and affects both the temperature and humidity. Now we discuss about the measurement of the pressure. How we will measure the pressure in any area. The pressure is normally measured in millibars. As we previously know that MB is called the millibar and it is the unit for measuring the pressure. The variation in the pressure are shown on maps by the mean of isobar. So, what is the isobar? Now we know that what is isobar. These lines are joining the places have the same barometric pressure. So, isobars are the imaginary line which connects the areas which have the same pressure condition. So, as we called it barometric pressure, the areas which have the same barometric pressure, and we connects this area by a line, imaginary line, that is called the isobars. The barometer consists of a long narrow tube filled with mercury, as we saw in this picture, like this cylinder like tube filled with mercury, and with the height of this mercury we can know the barometric pressure. As it is shown in this picture, that this is the glass tube that is inverted on a vessel, and this is the mercury level. Here it is created a vacuum, but the mercury ranges up to 29.92 inches, that we also called 760 millimeter or 776 centimeter. So which means 76 centimeter means 29.92 inches, and this is 29.92, and if we transfer the unit to millimeter, it will become 760 millimeter. That means the mercury level, which means 76 centimeter, the height of the mercury column. So after this we will know about the types of barometer, that is Fortin's barometer and aneroid barometer. There are two types of barometer, that is Fortin's barometer and aneroid barometer. This is the Fortin's barometer. Here is the mercury level, and here it is given the scales. After reading the scale, we will know about the atmospheric pressure by the instrument Fortin's barometer. And this is the aneroid barometer, from which we can know about the readings of the millibars. So this is how these two instruments are used. Now we will discuss about the term pressure gradient. So what do you mean by pressure gradient? Pressure gradient is defined as the decrease in pressure per unit area, distance in the direction in which the pressure decreases most rapidly. So in the other words, the rate of change in the atmospheric pressure between 2 points. As we know, if these are the 2 points, the pressure that is decreasing most rapidly between these 2 points is called the pressure gradient. So here it is written that, in other words, the rate of change of atmospheric pressure between the 2 points on the earth's surface is called pressure gradient. The rate, as we know, the pressure gradient is the rate or percentage of the change in the atmospheric pressure. On the wave chart, this is indicated by spacing of isobars. So if we will see an isobar map, so there is the isobar lines are like in this way. So some are near and some are very far. By this way, by reading these isobar lines, we can know about the pressure gradients. The gradient is steep if they are close together. So here it is written that if they are close together, these are the two lines of isobar. If they are this much close, then the isobars are steep. So if these are this much close, then they are steep isobars. And if they have a lot of space between the two isobars, then the pressure is gentle. Close spacing isobar indicates the strong pressure gradient, while the wide spacing suggests a weak gradient or low gradient or pressure gradient. So we covered the section of pressure gradient. Now we will go to the factors affecting the atmospheric pressure. Here, the atmospheric pressure depend upon the various factors that will affect the atmospheric pressure. In the first factor, here is altitude. The pressure that decreases with the height or altitude. So, previously we know that atmospheric pressure decreases with the altitude, which means if we go to a mountain area, the atmospheric pressure in the lower surface is very much high than the atmospheric pressure in the higher altitudes. The decrease in pressure is about 1 centimeter of mercury for every 110 of ascents. So, if we know that if we go to the mountain areas, then with the increase of height to 110 meter, then the air pressure decreases 1 centimeter. The atmospheric pressure is highest at the sea level. So, we can understand why in this height of the sea level the atmospheric pressure is high, because at the higher altitude the air is thinner or less dense than the air at the sea level. So, at the sea level, this is a mountain, and at the sea level this is the lower altitude. As we know, the molecules present in the higher altitude became less than the air molecules that present in the lower area. Near the Earth's surface, the density of the air is maximum. And the air density decreases with the height. Because why the air density decreases with the height? Because the pull of the Earth's gravity is less. So, as we go to the higher region, the gravity also decreases. The few number of gas molecules at the higher altitude means fewer molecules collision and a decrease in air pressure. Previously, we know that the air molecules present in the higher altitude are lesser than the lower altitude. So, in the higher altitude, the collision among the air particles is also less. For that reason, the air pressure decreases in the higher altitudes. So, the few number of gas molecules and the collision is also less, which decreases the air pressure. Since the atmosphere is highly compressible and the overlying layer exert pressure on the low-lying layer. So, here it is written that if there is a fewer molecule collision, molecule collision means if these molecules of air that closest to each other and make a collision, then the pressure will increase. And if there is a less collision, if the collision is less, then the temperature and the pressure also decreases. The pressure decreases. Since the atmosphere is highly compressible, the overlying layer exerts pressure. So, that is why it is called the air is highly compressible. Now, as the pressure decreases, the amount of the oxygen available to breathe also decreases. As we know, in the air there is 78% of nitrogen and only 21% is oxygen. So, if we go to the higher region, then the amount of pressure or the density of the air is also decreases. That causes decrease in oxygen available there. At the high altitude, the atmospheric pressure and the available oxygen get so low that people feel breathless. So many peoples that goes to the mountains or in the trekking somehow feel any dizzy type of condition. So because that happened, why that happened? Because the atmosphere, in that atmospheric condition or the higher altitudes, the oxygen level decreases. That why some people cause sickness in that altitude. Mountain climber use bottled oxygen when they ascend very high peak. So that's why, because there is an absent or less oxygen, not absent but less oxygen in the high altitudes, the mountaineer carry an oxygen cylinder. The mountaineer carry oxygen cylinder to get to the higher altitudes. They also take time to get used to the altitude, because quickly moving from high pressure to low pressure can cause decompression sickness. So it is a type of sickness that happen if we go from directly or instantly from high pressure to low pressure, that causes the decompression sickness. Decompression sickness is also called the bends. It is also a problem for scuba divers who come to the surface too quickly. As we know, under the water there is also a pressure that exerted by the air, and if we directly come or instantly come to the upper surface of the water, it also exerts some amount of pressure that causes this type of sickness. The aircraft create artificial pressure in the cabin so the passenger remain comfortable while flying. So as the aircraft is going to the higher altitudes, that means there is low pressure. So how we will suitable for the how we get suitable in that high altitude? Because there is low pressure. So that's why the aircraft create the artificial pressure in the cabin for the comfortable of the passenger while flying. The temperature rise and expand in that altitude. So that as we know that if we go to the higher altitudes, the temperature also rises and the air expand. What do you mean by air expand? The air molecules get separated and does not collide with each other. That causes the low pressure. So here the temperature rises and the air also expand, and the molecules of the air move from apart, which become less dense. As we know, if the air became less dense, the air pressure also decreases and hence exert less pressure. On the contrary, with decrease in temperature, the air get compressed. So if the temperature decrease, then also the air get compressed. Compressed means the space between the molecule decreases, which make it more dense. So and exert more pressure on the region. If the air get more dense, D-E-N-S-E, dense, the air also exert high pressure. That is why the equatorial region, which means near the 0 degree latitude, the equatorial region, this is the equatorial region, and it has a low pressure belt where whereas the polar region have high pressure belt. As we know, in the equatorial region, that is 0 degree latitude in the both north and south, this region experience a high temperature which creates low pressure, and because in the polar region experience the high pressure, because there prevails the lower temperature. Now we will go to the another factor, that is water vapor. So water vapor, what do you mean by water vapor? The water vapor is the gaseous phase of water, so which is produced from the evaporation of boiling of liquid water. If we boil the liquid water, then it transforms or evaporate and produce the water vapor. Water vapor concentration affect the atmospheric pressure. How it will affect the atmosphere? Because the molecular weight of the water is 18 gram per mole, which is less than 18 gram per mole, and which is less than the average molecular weight of the air, that is 29 gram per mole. So 29 gram per mole is higher than the weight of the water vapor, that is 18 gram per mole. And for that reason, when the water vapor enters the atmosphere as a gas, the water vapor molecules takes the place of the other molecules in the air. So for that reason, the volume of the wet air, the air that consists of water vapor, less than an equal volume of dry air. So the water laden air is equally less than, that is, it is higher than the humid air, that the air which contain water vapor. Therefore, the humid air is less dense and exert less pressure. So as we know, if the air get dense, it exert higher pressure, and if the air is less dense, then it exert lesser pressure than the dry air. After this factor, we will go to the another factor, that is rotation of the earth. So what is rotation? We all know that rotation is the movement of the earth in its own axis. So due to the rotation of the earth, the bulk of air at the poles is thrown away towards the equator, and this happens due to Coriolis force. So now we will study about the Coriolis force. So this is the Coriolis force which causes the movement of the air, and this is the equator, and these are the two poles, North Pole and South Pole. And here in the poles, the air is moved towards the equator, and this happened due to this effect, which occurs that object deflects to the right in the northern hemisphere, and in the object that deflects to the left in the southern hemisphere. So the air in the northern hemisphere deflects to the right of the northern hemisphere, and the air that deflects in the southern hemisphere to its left. So for this reason, the atmospheric pressure is affecting by the rotation of the earth. Since the equatorial region receives the great amount of heat throughout the year, the air became warm and light. So as we know that if there is higher temperature, the pressure is also high. So therefore, it rises and create low pressure. As we know, if the temperature is high, then the pressure becomes low. Since the equatorial region receives the great amount of heat throughout the air becomes warm and light, and therefore it rises and create low pressure. As we know, the area which get the higher temperature have the lower pressure. At the poles, the cold heavy air sinks down, and the cold air is equal to dense air. So at the poles, the cold heavy air sink down and create pressure. In fact, the temperature and the rotation of the earth together contribute to the formation of world pressure belt. So, in this picture, we studied that this is the equator and this is the North Pole and South Pole. And here, for the Coriolis effect, the air moves towards the equator. And this is from the northern hemisphere and this is from the southern hemisphere. So, in this way, the rotation affects the air pressure. This factor makes the air pressure an important parameter in predicting the weather. So, by predicting the air pressure, we can know about the air condition or the weather condition, as if there is the weather became stormy when the air pressure falls. As we know, if the air pressure falls, so in that region the air gets heated and the air moves to the upward direction, so which creates a vacuum in this area, and the air from the high pressure come in a high speed towards the low pressure area. So that creates a stormy weather. Generally, here it is written that generally due to the warmer humid air or convergence of the air masses at the surface of the earth, which causes convection and rising in the air. So from here we know that the convergence of the air masses at the surface of the air, which is caused by the convection and rising the air. So as the air getted warmer, the air rises in the upward direction, and the air present in the high pressure area moves swiftly towards the low pressure area, and which causes a stormy weather and became fair. And when the air pressure rises, generally due to the drier colder air or divergence of the air masses. When a low pressure system, and this became vice versa in the polar regions. In the polar regions. When a low pressure system moves into an area, it usually leads to the cloudiness, wind and precipitation. So from here we know that when a low pressure system moves into an area, it usually leads to the cloudiness, wind and precipitation, that is rainfall. So high pressure system usually led to the fair and calm weather. So where the areas where the high pressure prevails, there the weather is fair and calm. So in this lesson we have covered the factors affecting the atmospheric pressure. In the another lesson we will learn about the world pressure belt. That's all for today. Thank you.